Welcome to the DataStack Show. Today we are going to talk with Par, and he has a long history working with data. In fact, he was one of the first couple people at Talend who's been around for a really long time. And then he actually brought the Hadoop Spark infrastructure into Talend and really influenced the shape of the product, which is fascinating. And today he runs a consultancy and also a school that teaches data engineering. It's called the DataStack Academy. Maybe we can find out if he got the name from us. But I'm really excited to talk with him. Kostas, you know, I have a background in education, so I think one of the things that really interests me, you know, in terms of Par's school for data engineering is what are sort of the key foundational principles or tools that he thinks that a data engineer needs to have to build a foundation for a career. Because, you know, it can be hard to kind of distill that down. So that's what I'm going to ask about. How about you?
Yeah. First of all, I want to ask him about like the evolution of data engineering. He's been around for a long time, and he has been around like since like back then we didn't have like the term, we didn't use like the term data engineer, right? So it would be great to hear from him what's the evolution and how from whatever was happening in the early 2000s to today has changed. And also, of course, hear his opinion about what's going to happen in the future, right? So that's definitely something that I would like to discuss with him. And then, yeah, it would be great like to discuss a little bit more about the technologies and in general, what it takes to be a data engineer and how it feels to be a data engineer. Is it fun or is it not? Let's find out.
Let's find out and go talk with Par. Par, welcome to the DataStack Show. We're super excited to talk with you.
Thanks for having me. Thanks for having me, Eric. Super excited to be here as well.
Cool. Well, we've talked with lots of your friends as guests on the show, so it's only appropriate that that we can have you on as well. Can you give us your background and tell us what you do today?
Oh, thanks. Yeah, I feel like I'm already a cousin of the show. You guys have had almost like every one of my friends in the industry, and I always like, oh, there you go. Yeah. Oh man, my background. It's been a while. I think I've got just lucky and continue to get lucky throughout my career and my life. I was very lucky to be born in a house that my father was a civil engineer, but he really had a knack for computers. So we had like a IBM 8080 computer, you know, when I was like 4 years old, and I would load up my floppy disks and play my games. And one time I actually formatted our entire C drive, and that was not good. I don't know if you remember DOS, but if you do format and not specify the drive, it defaults to C, which is horrible design, right? It's like, that's exactly what it is. And then, I went to actually school for computer engineering. So I have a background in engineering and computer science. Worked actually as a chip designer for a little bit, but I would say I really got started lucky when I left hardware engineering, came to software engineering. I got connected with a company that you all might know now, very large company now, Talend, but I got very lucky when I got connected with them. There were just 3 or 4 people in US. So again, day one, like my laptop was on my lap. I was their only technical employee at that point, and pretty much grew with them, you know, as they grew to the US. So trained a lot of folks, brought and built a, you know, technical team around Talend on myself and, you know, around North America. Then we moved to like Asia and other markets. Got lucky again at some point in the middle there. One of our account representative was like, hey, there's this thing Hadoop I keep hearing about. Like, can you just figure out what this is over the weekend? So I went and downloaded it and finally got it to compile and work without errors, you know, fairly early on. And then I saw the value of it immediately. I was like, wow, this is the next thing. Like I got to learn this or I'm going to be obsolete. So I I started learning it, started contributing a little bit, and then later on got actually connected with some of the founders of Hadoop, Doug Cutting, Tom White, and all those guys in meetings, and that was just incredible. And being in that market, I moved to a company at the time, it was called Greenplum. They evolved to Pivotal. I was one of their big data Hadoop solution architects. So I was part of the elite team they would send out to fix problems, where there was like large, like 1,000 node clusters, and all right, here you have 2 days, go figure out why this is not working, or optimize this ETL process that they have, see what's wrong with it. Did that with some guys, like Don Miner, that you guys might know. We were part of that team. And then 2017, decided to kind of go and build things on my own, the dream that I've had. So started a consulting company. That consulting company is still something that I run. But just about a year and a half ago, it dawned on us that I work with a lot of people who've been in this industry for a while, and we've kind of been around the block, and we're like, wow, there's really not too much resources around learning to become a data engineer. So we decided to develop a curriculum around that. And it was just us working at nights after hours for a while, and then became more serious, and we just launched this program, which is actually, by coincidence, is called DataStack Academy. So it's a boot camp to teach people how to become a data engineer and the skills necessary for that. Yeah.
Well, that is super exciting, and I want to dig into sort of what I see as a nonlinear career path into data engineering, maybe as you compare it with, sort of software engineering and you getting, computer engineering degree. But really quickly, if we can, Talend has been around for a long time. It sort of predated a lot of the big trends that we've seen even over the last decade, say. So could you give us just a little bit of history, especially for the listeners who may not be as familiar with Talend, but when you started with them, what were they building? And when was that? Was back in the mid 2000s?
Yeah, 2006, I think 2005, 2006 that I got connected with them. Yeah, and they were still, I think it was still V1 back then.
Yeah. Wow.
Yeah, so originally, the field comes from data warehousing, right? And you take data warehousing and break it into the pieces that it has. And some of the things that we don't hear too much about anymore, like databases and MPPs, and that also has kind of gone away, those talks a little bit, right? But then the other piece of that, of course, was the BI, the reporting, and that's still there, of course. Everybody has to do BI. And one of the other spokes of that wheel was ETL. And data engineering. And back then, I think it was mostly known as extract, transfer, load, or ETL, in the process of getting the data to the point that is ready to be analyzed or viewed, by the BI tools. In Talend, we were an ETL tool. So in ETL, there's a lot of things that you do that I would say are mundane, right? It's everyday stuff that could be templated, like how you open a connection to a database, how you write the database, how you read a file. Those things can easily be templated in a data engineering job. So in Talend, we had made a very nice visual tool that made you be able to use those connectors to different data sources and data syncs, and drag and drop, couple clicks, and it was a code generator. I think that was really what was the differentiate of Talend early on, because a lot of the ETL tools like Informatica and so forth that were on the market, they had an engine behind the back. So you had to know their own language, and they had their own engine, but the Talend engine was just Java, and it generated Java code. So it also allowed you to do a lot of things that are not common. All the ETL tools would get you like 70% of the way there, right? But that 30% you still need to code, and you need to do something custom. So it allowed for developers to do that, but do the mundane things like just open a database connection, like all of that stuff, very fast visually. And then there was that shift again, I think, where the engine was quickly becoming MapReduce and Hadoop and Spark. So, and I was actually, my sort of design, again, to be very humble, but I was the person who started that kind of development at Talend. So I made the very first Spark and Hadoop connectors. And I was like, no, this, like, even Java is not going to suffice anymore. Like, we need to go to something that's highly distributed, highly parallel, like Spark and MapReduce. And so then we changed the connectors to produce those code versus just pure, Mojo or a jar file.
Yeah, very cool. No, it's really fun to get those little anecdotes of history sort of in the world of, the world of data that we live in, especially, I enjoy it, and I hope our listeners do too, comparing the things that, are just wildly different with, the things that are like, well, I mean, some of that sounds kind of functionally pretty similar to, some of the modern tooling, which is really fun. So thanks for sharing that. Okay, let's talk about the role of a data engineer, because it's something that, I mean, I would guess that a ton of our listeners have some sort of data engineering or data engineering related role. So it's certainly not a new term to anyone on the show. I don't know if we've actually ever stepped back to define the term. And that can be a little tricky sometimes, and a term's like super familiar, but we don't actually put a sharp point on it. But let's start with sort of the nonlinear pathways that people travel into data engineering roles. And would you say that happened for you? I mean, you started out as a hardware engineer.
Absolutely. And you hit that too. Like, almost every data engineer that I know probably has a different background. And we've all had that. Yeah. Some people come from a data sort of science, software engineer background, traditional, like, 4-year degree and followed by master degree. Some people come from a business intelligence background where they transform from being a business analyst. And some folks are just sort of self-taught. They come from, like, actually complete different backgrounds that I've seen. Even from, like, being a server or a bartender, and they learned everything, all the tricks to do so. So it is very interesting, and it's kind of, I think it's part of being a data engineer, because data engineer, as you said, that role is not very well defined. And in tech, we are kind of jack of all trades and master of none. Like, we know a little bit about a lot of different technologies, but we're not really master anything. And that kind of define what a data engineering does. Data engineer is like a glue within a company, right? Is the person who brings data from all the different sources that data exists within a company and meshes those together. So you do have to be connected with all the different arms of a company. You have to understand what those do, what those data mean, and you have to be able to bring those together. And that makes you kind of very essential to the company. It makes you very essential as the way that you have to actually know even the business of the company, what the company does. So like, what those data are and how to treat them. But you also have to technically then know how to grab the data from the different, applications that they're stored and so forth. But to give you an example, I like to kind of maybe start by an example, like what a data engineer does, like at something that we might all know or use, as like Lyft or a Lyft app, a rideshare app.
Yep.
Like, what does a Lyft data engineer do? Right? And data engineers I promise you that all of us have interacted with data engineers, right? They're always in the background. They're always there. You just might not hear exactly what they do because we're background people. We're not developing apps, right? We're not developing like web where everybody uses. So in a Lyft example, so, in a company generates data. So Lyft has people who go download the app, use the app, and that generates a lot of data. There's a lot of data as far as like you getting the ride. There's a lot of data as far as like actually the ride, like your GPS updates, where you go in, all of those stuff. And the app itself is usually developed by your full stack developer or app developers. But it's data engineer job to work with those folks to grab those data and then store it in a manner that can be analyzed and move it probably to a cloud, move it to the servers that it needs to be. So data engineer works with them very directly to do that data acquisition, right? But it's also data engineer job to hand it off to other folks like data scientists and business analysts who are the business side of that, who let's say do something useful with that data. Like for example, in data science, example could be in the Lyft example, like a prediction algorithm where you want to tell when I go to grab a ride, maybe the app tells me, hey, based on the patterns that we've seen, you might want to wait 15 minutes. It's going to be cheaper for you to get this ride. Or maybe it's like a notification. Maybe it's a anomaly detection where you're like, okay, as you're going through the ride, the app pops up and says, hey, your driver just seems to take too many wrong turns, right? It's like we've seen, like you've just taken, based on GPS data, you've taken too many wrong turns. You might want to know that, that, and those are like the data science or machine learning algorithms, but it's, again, the data engineer to provide the data scientist with all that data, and again, grab the results from the data science algorithms and provide that back to the user. So it's that glue role again. And even in the other sense is the data scientists typically work with a smaller data set, right? They work in a prototyping fashion where they only might have like developed a data science model looking at 1,000 or 10,000 population. It's data engineer task again to really operationalize those and in a company take those to the masses. Okay, now we take this data science model in this like prototyping phase, but now we're going to scale it to like the million or billion users that this company has. Make sure that data continues to come through the pipeline, come through the system, and all the users get the results. Right. So that's the data engineer role. Also, data engineers, we also the glue between all the different applications. So between your CRM application, sales application, all of that stuff, we play that role as well.
Okay, so super fascinating, and I love, and actually would love to hear from our listeners if you're listening to the show. Write in and tell us if you have a similar opinion, because we haven't defined it before. But that was super helpful, and I love using the example. One question I have actually for you, Par, and Kostas, because you both come from, actually, I think you both come from sort of you have like hardware engineering and software engineering backgrounds. In software engineering, and this is something I learned from being in an education business that focused on software engineering for a while. And our instructors were always very insistent on sort of teaching core principles because that was way more important than the specific syntax of a particular language, right? Like if you understand these core concepts of building software, you can apply them to different syntax within the context of a different language. Would you say that's true for data engineering as well? Are there some sort of foundational things, concepts, skills that you need to sort of master to have a really good foundation to sort of build a long-term successful career as a data engineer?
We should go first.
You want to take it, Kostas, and I can go second for sure.
Sure.
Yeah.
You are the guest, so you have to choose.
Perfect, thank you. I was taught that the host chooses, but
yeah, that's a very interesting question from Eric, and it's a question, to be honest, that comes up not only for data engineering but also for software engineering. What you're describing, Eric, is also the difference between computer science and computer engineering, right? For example, which is completely different disciplines, to be honest. Completely different. I mean, of course, they have overlaps, right? And if you are like a computer scientist, you can also become a computer engineer. But there is a reason that one thing is called a science and the other thing is called an engineer discipline. And one of the things that happens a lot, with the curriculums for software engineering, is that they are heavily dominated by computer science topics. That's my experience also, right? Like my degree is in electrical and computer engineering. But anything that had to do with like the computer side, it was like more of computer science, right? Like I had to prove the complexity of algorithms, right? It wasn't just to know the complexity of an algorithm. And I had to figure out like what tools you can use to do that and why we have, for example, like these different complexity classes and all these things. Now, there's a debate there, how much you need from that to become a software engineer, right? I'm biased, obviously. I like the science side of things. So I think that it's important to know that also when you move into like engineering. But the engineering track also has some very, very important elements that you need to know if you are going to build products and put technology into, like, let's say, make it useful for people, right? Everyday people. And that's, I think, what we are seeing happening also right now with data engineering. Like, I think the biggest, let's say, change that has happened, like probably in the past, like 1 to 2 years, is that all the principles that we have in software engineering or computer engineering, you see them like being applied in data engineering and how we deal with data, right? Quality, QA, tests, version control, like all these tools that a software engineer is using every day to go and do like deliver what they have to deliver. We start introducing them also into data. Now, do you need to have, let's say, there are like some kind of principles that are, let's say, fundamental? I would say it's probably the same thing with software engineering at the end. It's the same principles. I don't see like some huge difference there in terms of like how someone should shape the way they think in order to solve the problems there. At the end is again like engineering problems, and there are like problems that you are solving with software. And either you build software or you operate software. And I think that's like the main, the very interesting characteristic about data engineering. And I've said that like many times in the past, is that it's a hybrid between ops and software engineering, which maybe might change in the future. I don't know. We'll have like data ops and data engineering, and we'll be like to separate. I don't know. But for now, I think that the data engineer has to do both. So yeah, that's, I know it wasn't like the most straight answer, but in my mind, at least, I don't see any difference in the fundamentals between the two, between software engineering and data engineering at the end.
Yeah. It's kind of, I want to bring it back a second and say that how big actually data engineering is. And it's not just us, there's a lot of numbers behind this. There was a DICE report from the pandemic year where data engineering was the fastest growing field in tech. And they analyzed 6 million job postings in US for that. And it rose by 50%. It had double-digit lead over the second on the list, which was 32%, which was data science. So that's huge. That tells you everything, that this is a field that is the fastest growing field again in tech. And that shows in the salaries. So when you look at the salaries on Indeed right now, average data engineer salary is 119K. That's higher than data scientist, higher than full stack developer, higher than a software engineer. And I want to say that in some sense, we are very privileged to be data engineers, right? We have very comfortable jobs. We do have salaries like that. One of the other stats that Indeed posts is unlimited time off for data engineering, which I don't even know what that means, but I kind of do, right? Like we're very flexible. We work very flexible hours. We have great 401ks. We have great healthcare, and some of those are just not available to a lot of us Americans these days. And I want to kind of take that conversation to the folks, and to that sense that for the folks that are trying to get into this market, right? And what path they would choose, what do they need to learn to be a data engineer? And It is true. There's a lot of different paths that you would take, and even if you're in software engineering and you want to level up to be a data engineer, especially nowadays, be a cloud data engineer, I think that's very key. What do you have to do? I do feel like, from my experience, there are some things that I can say that would work. Yes, there might not be a general path, and if you look at a lot of colleges out there, they're just beginning to have like a Master of Data Engineering program. There's some boot camps now that do like a specific data engineering career. But here's what I think would work really as the path. I cannot emphasize enough the importance of being a cloud data engineer these days anymore. And if you want to, if you're on this self-learning path, start by actually looking at one of the cloud certifications. All the major cloud vendors, AWS, Azure, GCP, have now a data engineering certification. On their website, they actually list a lot of good free resources that you can go to learn the skills to be that person. I would also say it's very important, something that gets missed, that as we're doing things and as we're doing projects, you do those on GitHub. Now your GitHub profile, right? It's like the most important thing out there. A lot of companies, when they hire, they go on GitHub, and that's how they vet the resources. I do that myself because code doesn't lie, right? At the end of the day, you can look at someone's GitHub profile and see what they've done. The other thing I would say is to get your hands on a lot of real world projects. So there's sites like Kaggle, Data Hub IO, where you can go get a lot of these like real world data sets, real world projects, and then build those on GitHub, and be able to show that to employers later on. I would also say, there's tons of resources out there as far as like learning, where Data Camp and like Udemy, Coursera, all those courses that have like very budgeted, I would say, programs around that. But then there's also this other kind of learning path, which is your boot camps, and they're now just becoming some boot camps around data, and specific around data engineering, and they can provide some things that the other programs can't, right? So I think they provide this like declared intention that's by far the most effective. When you say you want to be a data engineer and you go through these boot camps, you sign yourself up for this like 3-4 month experience where you submerge yourself in data engineering, submerge yourself in learning. And there's just something magical that happens when people have that declared intention, right? They're like, okay, I'm going to do this. And second, I think the benefit they have is around that shared learning, right? When you're around other people that are just at your own level. And you can maybe replicate that a lot out there on your own too. There's Twitch is a great platform now. A lot of people like kind of learn together on Twitch. Somebody says, hey, on Wednesday night, I'm going to go learn this tool. And if you want to join me. We're all going to do it together. And that's a really great resource. I highly recommend that. But I think lastly, some of these boot camps then have career services. That's something that you probably won't be able to get anywhere else. And that would be very important, especially if you're new to tech, to have somebody actually advocate for you, somebody go and show you the ropes of where to get a job and how to get a job. That's going to be really important. That's short of my spiel on like kind of the path to data engineering. And again, I do want to really emphasize the importance of learning a lot of these skills on the cloud, and I see that's where the industry going. I do have a very opinionated opinion on the sort of 5 tools that you have to learn as a data engineer, because I know if you kind of go out there and kind of try to research your own, you would immediately become very confused with a lot of different opinions that people have in this stack that you have to learn, because we all know as data engineers, we're also very opinionated. that's for sure.
100%. Par, I have a question. What was there before the title of data engineer? Like, companies had problems with data like since forever, right? Like they had like to manage data. in a different way, obviously. Like we didn't have cloud back then. Data warehouses were like bundles of hardware together with software. But what was there before that? Like when you were in Talend, right? In mid of like 2000, how did you call these people?
That's a great question. Yeah, I think it's kind of evolved with the different technologies, right? So again, if you look at it, it was software engineering, and that kind of evolved to data warehouses, right? And that kind of evolved to data lakes, and now it's kind of data clouds. And if we backtrack that, I think some of the skills that we've had to pick up along the way, right? We went from data warehouses where it was very much an afterthought. You know, business intelligence in a sense is an afterthought. It's like after the events have happened, after the data has happened, you come and collect things and then make sense of it and say, okay, let's get the numbers on an aggregate level and see what happened, how much we sold, how much inventory we have. And it was very purely, again, an aggregation, kind of a very mathematical sense, right? We're now in kind of like the tens or the teens, 2010s, 2020 now time, that become much more real time. And that become that, and then we saw ML and machine learning and data science, right? So the need went, okay, not so much an afterthought, but what do we do now? Like this data is coming in. How do we interact with the user in an intelligent way? And how do we use machine learning and data science to give them some perspective of what they're doing and what, you know, give them some pointers. And I think that's where data engineering kind of grew alongside this data science, right? When in the modern world, a lot of these are real time. If I backtrack that just a little bit before that, you know, we could say someone was a big data engineer, you know, where, and again, even big data was to a point was again an afterthought, right? MapReduce and Spark was an afterthought. We just did it at a larger scale. Yes, like other things came like Spark and Kafka and other these technologies that made that again more real time. And that was kind of the shift. And now if we even step one level back from big data engineer, I think you hit it very right on where in the Talend days where it was like ETL developer, right? Now we're in data, really in data warehouse realm where you were an ETL extract transform loan developer. You worked alongside a business analyst, very close, and your job was just to provide pretty much the aggregate level tables to get from raw level data to aggregate tables, and then the business analyst put a visualization, a dashboard around that, and you know that went to the executives. And step beyond that, like when we were initially hiring at Talend, there was, yes, I would say you would be a software developer or a DBA, a database administrator, you know, something that you were just purely in charge of like storing data. And that kind of, I think that was like the evolution. So I would say like kind of software developer, right? Went into like ETL, and from there you went to like a big data engineer, and then big data engineer somewhere along the way meshed to data engineer, now like cloud engineer per se. Yeah.
Makes a lot of sense. Yeah, that actually, I think it's like a very, very good timeline of like what was there before and how it's, let's say, grew into the role of the data engineer today. Totally agree with you. So I have a little bit of a provocative question for you, based on also like the experience, the personal experience that you have by moving from like different roles, like from hardware to software, then become like getting into data engineering. Let's say I'm a software engineer, right? I write backend code. I don't know, something like that. Something a little bit more common. How do I know, or like what indications I might have that I'll be happy as a data engineer and it's worth for me like to invest and transition from being a backend engineer into a data engineer?
Another great question, Kostas. You nail it in the head. So there are some characteristics of a data engineer, I think personality-wise, that I've seen. There might not be good, but I would tell them. I mean, financially, like we can all agree that there are evidence that this is the fastest growing field in tech. It's not going away because data is not going away. It's not a hype, right? And we've all been through a lot of hypes in our career.
Yeah.
But at the end of it, it's data, and data is not going away. That's for sure. There's evidence that say, again, these DICE report that came out that ranked data engineers the #1, growing field in the field. There's the evidence of the average salaries for the data engineer, which is higher than any other field in tech again. So of course, there's financial benefits of being a data engineer. And you and I can both agree that we can both pick up the phone and tomorrow we have a job, right? Just saying our skills. So that's we're very privileged in that sense. Now, the personal characteristics of a data engineer, which kind of hurts me to say, is first of all, we're background people, right? Nobody hears our name. They hear our name mostly when things go wrong. If all the data gets to where it needs to go and everything's fine, nobody would come knocking on your door. But as soon as people don't get their notification, people don't say their emails, people don't, like all these apps fail, or there's a data breach or something like that, then everybody's gonna know your name. And people are gonna knock on your door. So in a sense, I like to say that us data engineers are kind of silent heroes. We're in the background, but nobody hears our name. We're the Q, right? In the Bond sense, right? I hate that I use that analogy, but that's somewhat true. From working with data engineers, one thing that we do, because in our field, the devil's in the detail, right? As a data engineer, you have to make sure that you've accounted for every piece that a software could go wrong, that accounted for all the corner cases. And in that sense, a lot of data engineers are very particular in the attention to detail. I want to say even like we're almost OCD, right? And we are, like, if you see my own apartment, it's very neat. I am very OCD. And in data engineering, but that's what makes a good data engineer, the attention to detail, right? So if you have those characteristics, I think data engineering is something good for you. If you are someone who thinks in steps, if you played with too much Legos as a child, you build pieces together. I did. I played with Legos till I was 13, unfortunately. And but that helps, because again, you have, as data engineering, you have all these pieces and you have to figure out how to put them together, and you build something bigger from that, right? Yeah. So those are some good facts. I would say the one thing that I want to debunk, if you're out there on the internet, a lot of people say that data engineering is too complex to get into. It's too hard to learn. I want to say absolutely disagree with that. And even like, I see where that is coming from, because people say, oh, because you have to learn Spark, and Spark this hugely massive, distributed processing engine, or you have to learn these things like Kafka. Again, this very complex software engineering concepts like distributed processing, right? But those things have been made so simplified now. Like it is Spark because a lot of smart people worked for years to abstract away all of that complexity and make it something very simple to understand and very simple to use. And I would say absolutely, like, anybody can go spend 2 weeks and be a very solid Spark developer, right? They can understand the concept of data frames. They can use it to aggregate data. They can use it to process data. And so that's the one thing that I want to completely debunk here. If you learn that data engineering is complex, that is untrue. And it's mostly like a little bit of gatekeeping talk that there is in a lot of tech, I would say.
Okay, Kostas and Par, question for you here, and this might be provocative as well, and maybe some software engineers who are listening may not like this, but one thing that's interesting when you think about software engineering is you're building something for an end user, right? So you want to develop empathy for the end user. So if you think about a software engineer going back to Lyft, as opposed to a data engineer, the software engineer you know, in an ideal world is trying to build empathy with someone who's trying to get a ride, to book a ride, right? And, you know, what are the, you know, sort of what's happening that creates friction there? And I want to have empathy as I build this, right? What's interesting about data engineering is your end user is someone in the business. So would you say that, you know, if you think about a software engineer, to your question, Kostas, and would love your take on this as well, Kostas, if you have kind of an interest in the mechanics of the business itself, maybe even beyond sort of the experience of the end user, that's kind of a false dichotomy, right? Because they're you know, inherently related. But you said earlier, Part, you have to understand the business, right? And sort of the way that it works and generates revenue and all that sort of stuff. Would you say that a predisposition to being curious about the business is a good sort of prerequisite for being a data engineer, or does that matter?
Well, you can go first on this.
I wouldn't say it's a prereq. It's something that I picked up along the way that I think that you can kind of pick up, and by necessity, you kind of pick up along the way a little bit. But yes, it is essential that you have those ears open, right? You have your eyes open, and you have your ears and listening for the ways that your process is making other people work easier. Like, right, just like you said, yes, like a software developer goes to a company to build, you know, empathy around the experience. Our job is to build empathy for that software engineer to make all the pieces that they need, that they can do their job, right? The platform that they need, and then again get the data, and also be able to grab data and then hand it to the again data scientist, and then tell again back to the software engineer, hey, these are the ways that your software is being used. Maybe these are some of the things that you haven't seen, and again make that loop possible, right? Yes, you have to know the business, because you touch, again, you are the centerpiece. You are the piece that moves data around a company. So you're gonna touch all sides of business. And it's very important when you are in those meetings with the different business stakeholders that you really listen. I think a big part of software data engineers' jobs, our job, is to listen, to be very honest. And then taking those things that you've heard, taken back with you, and turn it into requirements of what you have to do about your job. Yeah, how now that tells you how you should store the data that kind of matches those needs, those business needs, right? And so, and to kind of close that up, your empathy, like as a data engineer, I feel like we live for the process, right? Like, yes, maybe it's not that glorified app that we designed and we made it so much simpler for the person to click, you know, the buttons and get that right quicker, but we made that process possible. We made all those pieces work, you know, even though we were in the front facing of that, we're in the back, again, connecting the dots, right?
Yeah, I agree with Par. I would say, like, let's say we were interviewing for data engineer role, right? I don't think that I would pay that much attention on how much interested the person is, like, in the business itself at that point. I think that's relevant for everyone at the end who works in the business. If you ask me, for example, the first thing that comes to my mind when I was listening to you, Eric, is data analysts. Like, yeah, if we are talking about the data analyst, being curious about the business is important, because you have to understand, like, the business to go and do data analysis, right? And understand, does this make sense or it doesn't make sense? So you can go and figure out if something went wrong, like on working with the data. But for a data engineer, I don't know, as Par said, we are talking about, you know, people that are in the background, and that's part of how it is, and it's a good thing. I mean, it's not bad, right? Like it's not, there's nothing wrong about that. But you learn about the business, let's say, anyway, like you cannot not learn, let's say, about that. And that's like relevant for every engineering role, right? Go and speak like with someone in operations, for example, like they know a lot about the business, because depending on the business, they know if they have to be on call or not, right? So,
yeah.
I wouldn't say that there's some difference between like the data engineer and anyone else. The main difference that I would see there is that data engineers, the customer of the data engineer is internal, right? It's like the marketing team, it's the sales team, like the RevOps team or whatever. And it's not necessarily like, let's say, only the person who uses the Lyft app to call a Lyft and go somewhere. So that's the main difference. But I wouldn't say that like, okay, it's, oh, let's put it like in a different way. Let's say I have like a person who is more curious in the business than in the data related problems of like, for example, how much data you have to work with, and like what kind of systems you have. If someone was like more interested in the first thing and didn't ask any questions about the second, I would be worried. Probably there's something wrong with the career path of the person chose.
They need to be an analyst.
Yeah, I mean, yeah, probably. If I have someone who's really interested in the data related problems and also makes the connection with the business, that's amazing. But if it doesn't happen, that's again fine.
Yep. Yeah, I think that's a super helpful perspective. Okay, we're closing in on the end here, so we have time for one more topic. Brooks just let us know. One thing we'd like to chat about is, you mentioned a term as we were prepping for the show, Par, the modern data stack. Is something that we've discussed. I'd love your take on two things, and I'm sure Kostas will have some questions as well. You mentioned that you have pretty strong opinions about, what are the 5 tools that a data engineer needs to know. So I'd love to get that list from you, because we always love, an opinionated take on the tooling. And then the other thing I would like to know is, if we think back to 2005 and Talend, and then, Hadoop Spark, you've seen the, sort of modernization of the data stack. And there are lots of definitions for that. It's hard to nail down. But I just love your take on what is the modern data stack, and what does that mean to you in the context of what you've seen over the past decade and a half?
Yeah, great question. So if I had to really summarize it, I would say the modern data stack now, again, is the cloud, and it's on the cloud. And I'll explain that in a second. Let me get into the 5 tools that you need to learn. And these are, I would say, backed again by a lot of data, by that DICE report that I mentioned to you, that these are some of the skills that were top listed on those. I would say, as a data engineer, you got to learn the basics, right? The basic, and this is, I would say, number 1, basics. And I would categorize that as just your, basic bash terminal programming, Python, SQL. And I chose Python as my language. I know there's a lot of languages out there for data engineers, but Python by far is the most dominant one. And it's again, that bridge between data scientists and data engineers. So it's a great, and it's language, again, built for data engineering, right? The second, number 2, I would say Docker Kubernetes. That's becoming, especially for designing cloud agnostic data pipelines that work across clouds, and containerization. Now, everybody is now, on designing serverless microservice, these sort of architecture, which is, again, the part of the modern data architecture. And Kubernetes and Docker are the heart of that. And this was, again, the number, I think Kubernetes actually was the number 1 skill for data engineering in that DICE report. If you go to third, something traditional, it's been around there, your number 1 big data tool, Spark. It's still, your bash processing, billions of records, Spark is the tool to go. And again, it's very easy to learn Spark nowadays, because there's great documentation, a lot of good resources out there. Number 4, it's now I'm going to move to a little bit of stream processing and real-time processing. And this is a tool that is just a foundation for connecting almost all the data pipelines in a real-time sense, which is Kafka, right? Your Kafka, Apache Kafka. And number 5, I would come a little bit on the orchestration side, right? And there's a tool now that's becoming heavily dominant on the orchestration side, because again, as data engineers, part of our job is to connect the pieces together and orchestrate data flows for data pipelines, and that's Apache Airflow, right? Apache Airflow now is almost becoming the number one orchestration tool. But I want to now come back and say, as a modern data engineer, what I've seen in the industry in almost every project that I do nowadays, it starts on the cloud, and they're on the cloud, and everything's moving on the cloud. So you need to learn these skills on the cloud. The first 2 are agnostic on the cloud, right? Bash, Python, SQL, Docker, Kubernetes. That even cloud vendors don't even have a different name for a Kubernetes service. They call it Kubernetes. But the last 3, each cloud vendor has kind of their own version, and they call it something else, right? Spark, on Amazon, it's called Amazon EMR, and Google is called Dataproc, and Azure is Databricks, the company who's behind this Spark. Kafka on Google is called PubSub, on Azure is Azure is Event Hub, on Amazon is Kinesis, Airflow has different names, etc. And I say that again, that even in my own job, like I would say, we wouldn't even take jobs that are not on the cloud anymore because they take so much longer to set up and maintain. And that makes us to be able to deliver a lot later, even as consultants. And that's a bad thing in consulting, right? You want to go as fast as you can. And the cloud vendors just have made that so easy. They've removed all the complexity of managing these systems, all the complexity of the scalability. There is a huge move towards this serverless event-driven architecture, like the use of cloud functions. That is huge on the cloud. The cloud functions, they're event trigger. They're just small piece of code that you write that could do a data transform, that could do nearly everything. And the cloud itself completely takes care of the scalability, the fault tolerance, all of those topics that we have to worry about. Immediately your function can scale to millions of data points, and it can be triggered in real time to act on data. And they're so easy to deploy. With one bash command line, you can deploy your code running from your machine to the cloud that is scalable to millions and millions of instances. That is so powerful these days. And if I take a step back again, I think it's in a modern data stack, there is a distinction between solutions and products. And we have to be very careful with that. There are a lot of different products that are out there, but there are very few solutions. And I want to say, like, product is like if you think of product as like in a building a house sort of analogy, a product is a nail gun, a solution is a framed house, right? And so don't get bogged down so much as far as the products, I would say. And clouds are kind of solution now because they give you all of those products. They give you that framed house almost. And there are some other, of course, there's other solutions out there, something like Snowflake, Databricks. Those are now solutions. They provide like a need, they provide a need that they're not a product. There are a lot of products out there, like products around like different ML, different machine learning libraries, a different like audio processing library, different video processing library, code security, scanning code, for faults. Those are, again, products. And at the end, those products, I think, would move to cloud at some point in the near future, right? All of those products, all of those technologies, if you're on their board, they're kind of like, okay, what do we do if we sell to one of these cloud vendors at the end of the day? That's the exit strategy, right? So coming back to the solution, I think it's very important in the modern data stack. What are the companies that are providing that framed house, right? And that's very important for us to look at. Again, as far as being a data engineer, just going back to those: Python, SQL, Kubernetes, Docker, Spark, Kafka, Airflow. I think if you learn, I know that's more than 5. I kind of do Python and SQL as 1. Yeah. But if you learn those on the cloud, I can guarantee you that you would have a job in this industry. That gives you the base. You can learn everything else from there. Yeah.
This is great, Par. One last question, and I think we can conclude like this conversation today. I mean, although we have to have at least another one, I think there are like many things that we can discuss, and there's value like in doing that. So let's say I want to take a taste of data engineering, right? Like I'm not a data engineer. Can you give me like a sample, like small project that would be like a good way for me to take a taste into what it feels like to be a data engineer, something that potentially I could also put, let's say, on my GitHub and I can demonstrate it?
Yeah. Well, I would highly recommend going on Kaggle, right? Kaggle has like even data, like they're great data science, data engineering tool. They have a lot of challenge projects that you can actually like get into these live challenges where you're competing with other data engineers and data scientists. But you can look at the historical projects that they've had, pick up on some of those. I think that's a great source. There's tons and tons of examples and projects there, and projects that have data with it. So, and I know you kind of can agree to this, Kostas. It's very hard to get your hands on big real world data sets.
100%.
Yeah. And there are some sites for that too. Data Hub IO, I think, is a good site for that. There's a lot of governmental agencies like. In our course, we actually took all the flight data. So FAA publishes all domestic flights data, like where these flights took off, where they were going, what airline. A lot of that is public data, and we use that, and it's a great volume of data. We use that to build our course. And not to take this opportunity to promote our program, Data Stack Academy, but we do have a lot of these projects. Actually, the first 2 chapters, we have a 10-chapter course. The first 2 chapters are free. If you go on our site, datastack.academy, there's a site to get started for free. We actually send you 2 chapters that has a lot of these projects, has, again, that data set, this FAA data set that we're talking about. And you can get started. There's a lot of good projects there, and we force you actually to go on GitHub, so you have to develop those on GitHub, kind of by design. Yeah,
that's amazing. That's amazing. Eric, anything else that you would like to add?
This has been a great show, Par. We really appreciate you taking the time. And it's been fun to just hammer on the definition of data engineer and talk about some of the specifics of the role. I think that's helpful both for people looking to get into it and people who've been doing it for a long time and even running teams. So appreciate the perspective.
Thanks again. Thanks so much for having us. I'm a huge fan of the show, long-time listener. You guys are doing amazing stuff. Please continue, do what you're doing. And we really appreciate you as listeners.
Well, thank you so much. We love that feedback. And if anyone's listening, please give us feedback. You can do that on the form on our website at datastackshow.com. So thanks again, Par. All right, Kostas. Well, why don't you answer the question? Is being a data engineer fun or is it not fun?
I don't know. I would say that it's fun. But I think that's the outcome of this conversation that we had with Par, and what is interesting, really interesting. It's not that much like about, okay, we discussed about the technologies and all these things, but it was very interesting to hear from him also the personality traits that someone has to
Sure.
become like a data engineer. And I found this like super interesting. So it's not for everyone, obviously.
Sure.
But there's huge demand out there. So if anyone's like thinking about it, give it a try.
Yeah, for sure. I think one of the things that this is at the very beginning of the episode, but well, Par mentioned this in the middle of the episode. Data engineering is so big. And I thought, I mean, that's a simple statement, but it's really true. And one thing that I recalled from the early part of the conversation when he said that was when he was talking about the early days at Talend and how, it was so cool that they output Java code that you could use to sort of customize that last 30% of your pipeline that you're building. I thought, I bet we have listeners who might, not be familiar with Talend because, they're young and they're early in their career and they're just using a completely different set of tools. And we probably have other listeners who remember when Talend implemented, the Hadoop Spark componentry, and that was game changing. And I just thought, man, data engineering is big. And it, now spans multiple decades. And it's just fascinating. It's really fun to just be able to talk about things that that hit on both the history and the modern stuff that we use. So that was my takeaway. I appreciated it. The history lesson, if you will.
Yeah, absolutely. And hopefully we will have him back like in the future. We have many more topics to cover with him.
I know we need to actually have Brooks start bringing some people back on because we always say we're going to do that. And then we get busy and we don't do that. So we'll, that's our New Year's resolution for the DataStack show. All right. Well, of course, subscribe if you haven't. You can get notified of new episodes and we'll catch you on the next one.